Hello, my name is Gregory Vivoso, Systems Manager of Strategic Communications, and the Adrestia Mars Initiative presents a new challenge for humankind and new focus for the education of our children. From Columbus in 1492 to Neil Armstrong in 1969, exploration is a key part of human nature and has led to massive development in each case. This mission will emphasize international cooperation in order to step foot on Mars while inspiring future generations to come.
Hello everyone, my name is Alexander Sims and I'm the System Manager for Mission Integration. So the mission statement includes mission objectives, mission users, concept of operations, and constraints. The objectives the mission needs to accomplish are to land a human crew on the Martian surface, to establish a sustainable surface base, and to return scientifically valid surface samples back to Earth. Mission users include the general public, and the general public benefits through spin-off technology and new educational materials. NASA benefits through scientific gains. JAXA benefits through reduced costs and increased resources, and SpaceX benefits through increased publicity and increased profits. Some constraints the mission faces are conducting the mission between the year 2035 and the year 2050, having a maximum mission duration of 10 years, and returning between 50 and 1,000 kilograms of scientifically valid surface samples.
My name is Natalie Gracer, and I'm the Deputy Systems Manager. For the mission to be successful, we will be having 8 launches from Earth. 6 will be cargo, 1 crew, and 1 Orion rendezvous. The first cargo launch will be from Cape Canaveral on October 25th, 2037, carrying the MAV to Mars, which will land on August 29th, 2038. After 5 more launches of cargo, the crew will launch on May 7th of 2044 from the Kennedy Space Center and arrive on Mars to a pre-made base on March 11th, 2045. After a 283-day surface stay, including collecting samples and establishing the base and going on sorties, the crew will depart from the surface of Mars on December 19th, 2045, and rendezvous with the Orion capsule in Leo. And then on August 13th, 2046, the crew will return to Earth.
Good afternoon. My name is Colleen Malley, and I'm the Systems Manager for Science and Surface Operations. The science goals that will ultimately drive the mission were determined by referring to the Mars Exploration Program Analysis Group's MEPAGS goals. On the surface, signatures of both extinct and extant life will be searched for. Furthermore, both past and present atmospheric conditions will be classified in order to better understand the underlying environmental processes occurring on Mars. It is also imperative for this mission to better understand Martian geology, due to the fact that this will help scientists on Earth understand the geological traits of both Mars and Earth. Lastly, during transit and during the surface stay, experiments will be run to help crew members plan for sustained human presence on Mars.
Hello, I'm Ashley Dowd, Systems Manager of Mission Transit, and our job for this mission is basically to get all elements, both crew and cargo, necessary for this mission off the surface of Earth, onto the surface of Mars, and in turn return the crew safely back to Earth.
Hi, I'm William Rawson, Deputy Systems Manager for Mission Transit, and the requirements that are set upon Mission Transit are to launch the crew to Mars and return them safely back to the surface of Earth, launch between the years of 2035 and 2050 with a maximum mission duration of 10 years from the first cargo launch date to the safe return of crew, return 595 kilograms of scientifically valid samples back to the surface of Earth, and to launch all necessary supplies and infrastructure into low Earth orbit, transfer those supplies to low Mars orbit, and safely land them on the surface of Mars.
Hi, my name is Lucas Langer. I am a ConOps specialist for Mission Transit. During the months of October and November 2037, we will have 3 cargo launches. These launches will land on Mars during the months of August and September 2038. The rockets that will launch these cargo supplies will be one SLS Block 1 or Space Launch System, and the other two will be Falcon Heavies. Included in this block of cargo launch will be our Mars Ascent Vehicle, or MAV, along with the In Situ Resource Utilization, or ISRU system, which will allow it to make its own fuel while on Mars. Our fourth cargo launch will take place during December of 2039, and it will land on Mars during October of 2040, and that will also be a Falcon Heavy. Our fifth cargo launch will be a JAXA H-2B, and that launch will take place during January of 2040 and land November that same year. Our final cargo launch before the crew leaves will be an SLS Block 1, and it will launch during April of 2044, and it will carry the CTV, our crew transit vehicle, along with the supplies needed for the journey into low Earth orbit, where the CTV will begin self-construction.
Hello, my name is Gabriel Perez, and I'm a ConOps specialist as well. So, once the CTV is self-assembled in orbit, the crew will be launched in a Falcon Heavy from Kennedy Space Center. The Falcon Heavy will be carrying a Dragon 2 capsule. The Dragon 2 capsule will rendezvous with the CTV in low Earth orbit, or LEO. Once the CTV and Dragon capsule have rendezvoused, the CTV Dragon combination will transit from LEO to low Mars orbit, which is a 308-day duration. Once the CTV has reached low Mars orbit, the Dragon 2 capsule will detach and descend to the surface of Mars. Once on the surface of Mars, the surface operations team will stay for a duration of 283 days, at which point the crew will get onto the Mars Ascent Vehicle with a sample size of 595 kilograms and return to low Mars orbit, where they will re-rendezvous with the CTV. The CTV will then approach Earth to enter a high eccentricity orbit. In July of 2046, an SLS Block 1 will be launched with an Orion capsule and will be placed in a high eccentricity orbit and will rendezvous with the CTV, and the crew, along with the samples, will be placed inside the Orion capsule, and the Orion capsule will descend with its EDL systems and splash down into the Pacific Ocean on August 13th, 2046.
Good afternoon. I'm Alex Klenk, and I was the Entry, Descent, and Landing, or EDL, specialist for this mission. The first system that will use an EDL system will be the Mars Ascent Vehicle, or MAV. The MAV will utilize first a hypersonic inflatable aerodynamic decelerator, which you can see in a rendering of in the bottom right. That will slow the MAV from its transit velocity down to supersonic speeds. Following this, it will use supersonic retropropulsion to reduce its velocity to zero and to land on the surface. Next up will be the 4 cargo missions. They also use HIAD systems. Following the use of the HIAD, they will use supersonic inflatable aerodynamic decelerators, or SIADs, to further reduce the velocity. And following that, they will again use supersonic retropropulsion. The crew will land on the surface of Mars in the Dragon 2 capsule. The Dragon 2 capsule will first use its solid heat shield to slow down as it enters the Martian atmosphere, and then it will use supersonic retropropulsion to land. As our Earth EDL system, we'll be using the Orion capsule. The Orion capsule will meet up with the CTV in a high eccentricity orbit. The crew will transfer to the Orion, and they will return to Earth. The Orion is optimal for this mission, this component of the mission, because of its ability to carry a high payload and because of its ability to take the re-entry heating from that high eccentricity orbit. The Orion would splash down the Pacific, and while on Mars, the cargo and Dragon 2 would land inside inside Daobalis, and the MAV would land on the plateau to the east because of the larger landing area.
Quick question on your sample return capabilities. You mentioned that the MAV will carry the 595 kilograms of samples off the surface of Mars, and those samples will also be transferred over to the Orion capsule for Earth entry, descent, and landing. But you also have an additional 450 kilograms of support equipment for those samples. Have you factored that additional mass into your calculations, and can your vehicles accommodate that?
Yes, to start with, for the MAV has a good bit of extra delta V at the moment, partially because of some uncertainty with other components of it, but also just to be sure that we can accomplish all the goals that we need. For the Orion, we are less sure. We're still researching some of those possibilities of how we're going to return those samples to Earth, with some adaptations to the Orions that will reduce the mass of the Orion itself. It's possible that we can do that, and that's why we included in our current mission. We believe that that would be feasible at the current time, but we're still continuing research to see exactly what the feasibility of that is.
Good afternoon, everyone. My name is Pranav Sridhar, and I am the systems manager for the Human Factors team. So as a Human Factors team, we are obviously in charge of keeping the crew alive during transit and surface day. And as a result, we've also, along with this, we've established 3 more requirements which must be met. We must institute the power systems in habitat, and we also have to be in charge of constructing the habitat to facilitate a safe and nurturing environment. Furthermore, we have to also be able to use the ISRU, which is the in situ resource utilization, for propellant and also some consumables. Additionally, we have also established 3 topics as part of the human science research goals, which concern microgravity, radiation exposure, and also the confined or isolated environment on the Martian planet. And furthermore, these overall drive goals to maintain the physiological and also the psychological health of the crew, and furthermore to compare the efficacy of the ISRU systems.
Hello, my name is Veda Nagubandi, and I'm the Deputy Systems Manager of Strategic Communications. Our mission name is Adrestia, and she is the daughter of Mars. In Greek mythology, she journeyed to accompany her father in his quests to fulfill her curiosity, paralleling the curiosity and ambition to reach new heights of our mission. Furthermore, she is the goddess of equilibrium, therefore representing NASA's mission support objective and representing general trends in STEM fields towards equal opportunity.